Hi guys, welcome to my YouTube channel. I'm Mike Tibello. I'm a tutor with MTech Tutorial Hub. MTech Tutorial Hub is a platform where you learn mind-blowing tutorials ranging from computing, innovation, technology, and even social life. Without much wasting of your time, today we're going to look at logic gates. What are logic gates? That's the question for today. Logic gates are electronic circuits capable of making logical decisions. They are basic building blocks of digital systems design. Logic gate can have one or more input signals and an output, which is a logical combination of the inputs. In computing systems, the symbols 0 and 1 indicate two possible states of a circuit or device. Logic gate can be represented as symbol, circuit, switch, voltage, or as a statement. The symbol we represent it using 0 and 1, and as a switch we will represent it on or off, and on a switch we represent it as open or close. As a voltage, low or high, next statement, false or true. Now, off in a circuit meaning is 0, and on a circuit meaning is 1, and on a switch whenever it is open meaning is 0, whenever it's closed meaning is 1, whenever it is low in terms of voltage it means it's 0, whenever it's high meaning it's 1, whenever it is false in terms of statement meaning it's 0, and whenever it is true it means it's 1. It's very important if you can get this concept. Logic gates operate based on a logical algebraic system known as Boolean algebra. Boolean algebra, which has two answers, 1 or 0, 0 or 1. In this system, the variable used can assume only one of the two values, that is 0 and 1. In today's lecture, we will cover OR gate in details, and on the subsequent videos, we will be treating AND gate, which this will be a prerequisite for the subsequent video, which is AND gate. I recommend you watch this one first before watching the other videos, because this will give you a lot of knowledge before getting to knowing the other ones. This is a symbol of an OR gate. This is an OR gate with an input A and B, which means it has two inputs and an output. Two input A and B and an output C. What is an OR gate? An OR gate is a logic gate that performs logical OR operation. A logical OR operation has a high output 1 if one or both of the input to the gates are high, 1, which is represented by 1. If neither input is high, a low output 0 results. OR gate produces an output 1 when any or all of the inputs are 1. It is therefore also called an any or all gate. That's another name for OR gate. Any or all gates. It's very important if you can store this at the back of your mind. Now, we're going to look at our first example on OR gate. An example 1, OR gate with two inputs A and B and an output C. though actually on the result that we have there, we represented our output using a plus b, which is this. We represented using a plus b. Now we have two inputs, a and b, and the output is a plus b. Now, how did we come about these digits? 1, 2, 3, 4 digits. How do we come about it? It's very important we pay attention to this. Now, we got this using a formula 2 raised to the power of n, where n is the number of the input. We have two inputs, that's 2 raised to the power of 2 will give you 4. Now you have 4 digits vertically you have 4 digits, 0, 0, 1, 1. You have 4 digits here vertically. Now we start representing your first input as 0, 0, 1, 1. Then this next one, which is b, we represent it not 0, 0 again, but 0, 1, 0, 1. And this is our output, a plus b. This is our output. Now, whenever you are having either one of a or b is true, then your a plus b will be true. Assuming if you are having 1 here, then 0 here, meaning your a plus b here will be what? 1. And when you are having 0 here and 0 here, you have 0 as your output. Or when you are having 0 under a here and you have 1 under b here, you have 1 as your what? As your output. Now look at this. You have 1 here, you have b under b here, you have 1, and here you have 0. Now either one of a or b is true, then your output will be what? Will be true. Now here it is. We have 1 here because your b is true, even though your a is what? Is false. Now you move to the next one. You have a as what? A as true and b as false. You still have what? True, because the formula said that either one of the two is true, then the output becomes true. When the two are false, then the output becomes false. Now look at the last one here. You have 1, 1. Both a and b are true. Then the statement a plus b is what? Is true. Let's look at the practical example for 2 inputs. A practical example of OR gate is shown here. Look at it. Now this is a switch A and B. That's this is our input A and B, and we have a bulb here. Whenever A is closed, now you have a light or an electron passing from here to this bulb, and this will glow when A is closed. And when both A and B are closed, you still have this bulb glowing. And when all A and B are open, this bulb here would not glow. That's a practical example of an OR gate. Now we'll look at example 2 of an OR gate with 3 inputs, A, B, and C, and an output X, which is A plus B plus C. We'll look at the truth table. Now, how do we get this? We apply that same strategy for getting this. Now this will be 2 raised to the power of what? Raised to the power of 3. That's 2 raised to the power of n, and our n is the number of inputs. Now in this case we have 3 inputs, A, B and C. 2 raised power of 3 will give you 8. You have 8 digits running vertically. 1, 2, 3, 4, 5, 6, 7, 8. Good. You represent the first input as 0, 0, 0, 0, 4 zeros. Then the next one will be 1, 1, 1, 1. That's 4 ones consecutively here. Then the second input, which is B, you represent it 0, 0, 1, 1, 0, 0, then 1, 1. Then the third input, you represent it as 0, 1, 0, 1, 0, 1, 0, 1. Now we can now look at the output. We can now get our output from this. Now you have 0 here, B, you have 0, and under C you have 0, meaning you have 0 all through, then your output will be 0. Now the second one, you move. Now the second one, you have 0 as your input, you have 0 as your input here. Also you have under C you have 1. Since we are having 1 here, now as an output, the output will be what? Will be 1. Now you have 0 under A, and under B you have 1, which is true, which is equivalent to true. Then under C you have 0. Now this has qualified the whole thing to be true, which is 1. Now here you have under A you have 0, 1, 1. Now this qualifies the whole statement, the whole values to be what? To be true. Now you have 1 under A, you have 0, 0, which is equivalent to false. Under this, so you have 1 here, and this qualifies it to be true. Here you have 1, 0, 1. Since you're having 1, 1, if you're having 1 in either A or B or C, that means your output is 1, is true. 1 here, you also have 1 here, you have 0 here, meaning you're having a true. Now under this you're having 1, 1, 1, which is there, but the A and B and C are true, meaning your results X will be what? 1 here. And that is how we got this. Now look at the practical example for the 3 inputs above. Now we have the inputs A, B and C as we have represented there. Now when you're having both A and B and C are open, now meaning this block or this bulb here or bulb here cannot have light. But when one of these switches or this input are closed, meaning you have light here. If this is closed, then you have light here. Even though this is open and this is open, you still have light here. Now I will leave you with a homework or a classwork. Try and do this yourself. Try and draw a truth table for the OR gate below and a practical example for it. Look, you see it has A, B, C, D, E, F. All these are what our inputs, and we have our final output as Q here. Boolean equation. The Boolean equation for the OR gate is A plus B plus C. That's when you are having 2 inputs. When you are having 3 inputs, you can have something like A plus B plus C is equal D. This operation is also applicable for an OR gate with more than 2 input, as I've rightly said there. Please don't forget to like, comment and subscribe to my video tutorial for you to be connected to more of our interesting videos. Give it a thumbnail and encourage us. Thank you very much. Love you.